Okay, welcome to Probability Day 2. We're going to be talking about permutations today. If you wanted to follow along, this is chapter 13.2 in your book. If you want extra help or you just want to work on some extra problems, you can go there and try some on your own. Remember, the odd problems have the answers in the back, so you can check your work against that. All right, now, again, make sure you have a pen and paper handy. It'd be hard to take notes without it. There's going to be some questions at the end that I check, so you want to have something to show me, especially in case you happen to have a pop quiz next time that I see you. Hint, hint. Okay, so let's go ahead and get started. A permutation is an arrangement of objects in which order is important. So this right here, I want you to make special note of that, because this differentiates it from something that we're going to be covering a little bit later on. So if you're going to make a note to yourself about vocabulary, just make a note that says permutation. Order is important. Big, bold letters, underline it, do whatever you need to do. Now, what do I mean by that? Well, take the letters that make up the word cat, for example. And I wanted to find how many different ways we can arrange those letters. Because, again, order is important. So the way the letters are arranged, as long as it's unique, is important here. So I could do ACT, ATC, CTA, CAT, TAC, and TCA. Those are all permutations of cat, and there's 6 of them. So 6 would be your answer, because there are 6 unique arrangements of the letters that make up the word cat. Now you could sit there and you could write all that out, and it wouldn't take too terribly long for that one. But now let's say I asked you how many ways you could arrange the letters in the word bear. Or how many ways you could arrange the letters of the word mouse. Well, there's more letters, which means there's going to be more arrangements, and that's going to take more time. So let's see if there's an easier way to figure it out. Well, there are 1, 2, 3, 4 letters in the word bear. So we write down 4, and we put this after it. Now, that's not an exclamation mark. I'm not saying 4! What I am saying is that it's called a factorial. So 4 factorial translates to 4 times 3 times 2 times 1. Your answer would be 24. So there are 24 unique ways that you could arrange the letters that make up the word bear. Now let's see if you could figure out mouse before I do. Okay? There are 1, 2, 3, 4, 5 letters that make up the word mouse, which would be 5 times 4 times 3 times 2 times 1. And what does that equal? 120. So there are 120 different arrangements of the letters that make up the word mouse. You get it? And just let's go back to cat just to make sure this works. There are 3 letters in cat. So it would be written like that. And you could do 3 times 2 times 1, which would be 6, which is exactly what we came up with. Okay, easy stuff is out of the way. Suppose you want to find the number of ways that you could arrange 4 of the letters in the word Mustang. Okay, now I know there are 1, 2, 3, 4, 5, 6, 7 letters in Mustang, but we only want to arrange 4 at a time. So to do this, there is a formula to do it, the permutations formula. Now there's 2 variables. There's N and there's R. N stands for the number of objects total. In this case, we said N equals 7 because there are 7 letters in Mustang. R is the number of objects chosen. And we are arranging 4 of the letters. So R is your 4. Now what do I do with those variables once I have it? Well, you use this formula here. Okay, the P stands for permutation. Now we just replace those other letters with what we've designated them as. So when you see an N, you put a 7, and when you see an R, you put a 4. So we would say this equals 7 factorial over 7 minus 4 factorial. Now remember order of operations, so you have to do what's in the parentheses first. So that's 7 factorial over 3 factorial. Now, when you expand this, what I want you to do is first write that on the bottom and leave it alone. And then on top, 7 times 6 times 5 times 4 times 3. And when you get to the number that matches there, go ahead and put the factorial after it. You can do that because if you were to keep expanding this, it'd be 3 times 2 times 1, right? Well, 3 factorial is 3 times 2 times 1. And we stopped there because we have a 3 factorial on top and 1 on the bottom, which means, wait for it, you can cancel them out. So all that's going to leave you with is 7 times 6 times 5 times 4, which equals 840, which would be your answer. Now, there's another way you can do this. I will show you in class the next time that I see you if you'd like to know, but I wanted to show you just this way for now, and we'll also be showing you how to do this on the calculator for the next class, so we'll be spending a bit of time on that. But it's important to understand what you're doing when you're just pressing buttons on your calculator and solving it. I want you to understand where it comes from and how it works, okay? Because for the simpler ones, sometimes it's easier to just figure it out without even messing with the calculator. All right, now let's do an example here using the formula, and I'll put it here so that you have it again. Okay, now, these are pretty common. Suppose your house has a 10-digit keypad to key in the code to open your garage. And this code is 6 digits long. So how many permutations are there? In other words, how many combinations of 6 digits using this 10-digit keypad are there? Well, figure out what your N is first. Your N is what? Well, it's a 10-digit keypad, so N would be 10. Your R would be 6 because we're choosing 6. The code is 6 digits long. So you'd write it 10, then you put 6, and then 10 factorial over 10 minus 6 factorial. So just so you see where I'm getting these from, the 10 is the total number of objects, choices, or in this case, keys on the keypad. 6 is the number of keys that we're choosing. 6 is how many digits long or how many keys long the code is. So you do 10 minus 6. So that gives you 10 factorial over 4 factorial. Now when you divide like this, you do 10 times 9 times 8 times 7 times 6 times 5 and stop there because that is our number on the bottom, right? And then we can cancel those out, which is going to leave you with that. This is where the calculator comes in extremely handy. So when you have that for your answer, you get 151,200. So there are 151,200 unique 6-digit codes that you could have to get into your garage using this keypad. All right, so hopefully you know kind of how this works now. If you have any questions, do me a favor, write them down on the paper that you have now. If there's something you're unsure of, make a little star next to it in your note. Ask me about it tomorrow, and I'll be sure to straighten it out for you, okay? Now, the questions that I'd like you to answer on your paper, can you think of an example of a real-life permutation that you use every day at school? And then go ahead and try this one out. The school is doing a lottery using the numbers 1 through 20. Only 6 numbers will be picked, so we're only choosing 6. How many different permutations of numbers are possible? So go ahead and do that, and I look forward to seeing you guys next time in class. And hopefully you're looking forward to the next video, which will be on combinations. Okay? Have a great day. Thanks, guys.